Okay, problem 7. Use the intermediate value theorem to prove that fx, which is x cubed plus 2x minus 4, has a root. Okay, prove that it has a root in 1, 2. Okay, so how do you prove that? First, to use IVT, you want to make sure fx is a continuous function, right? Because here fx is a polynomial, so it is obviously a continuous function. So you can just make the statement fx is continuous in the closed interval 1, 2. Okay, and the second part you need to check the value of fx is positive and negative, right, at different ends. So you can check that by substituting x with 1, which is 1 cubed plus 2 times 1 minus 4, which is negative 1, right? This is smaller than 0. And what is f2? f2 is 2 cubed plus 2 times 2 minus 4. It is 8, right, which is positive. So at one side it is negative, at the other side it is positive. That's why it is by intermediate value theorem, we know that. So by the intermediate value theorem, okay, we know that there exists at least one solution. There's at least one solution. Okay, a solution of fx is equal to 0 in the interval 1, 2. Okay, so that's the first part of problem 7. Then the second part of problem 7 is to find that solution by Newton's method. Okay, find the root to 5 decimal places. So what does that mean? That means you have to keep using the Newton's method until the first 5 solutions, the first 5 decimal places of 2 consecutive solutions are the same. Okay, so where should we start? Okay, theoretically we can start from any point. Right? We can start from 1, we can start from 2, we can start from the middle point 1.5. Okay, but to match the answer, so we start from 1. Okay, it's just for the purpose of matching the answer. So the updating formula of the Newton's method is xn plus 1 is xn minus fxn over, all right, f prime xn. So for example, x1 is going to be x0 minus, so what is fx? Okay, let's copy it down. It's x cubed plus 2x minus 4. Okay, what is fx derivative? It's 3x squared plus 2. Okay. So for example, x1 is x0 minus fx0 over f prime x0. Okay, so x0 is 1. Then fx0 it is, right, it is f1. Okay, minus f prime at 1. So here you just do the substitution, right? You just do the substitution, then you will get the answer. It is 1.2. Okay, can we stop here? No, because 1 and 1.2, they are too different. Okay, so we have to keep the substitution going. So we update for x again. So now x2 is x1 minus fx1 over f prime x1. Okay, so you just do the substitution again, you will get the answer here. It is, okay, it is 1.179747. Okay, can we stop here? Again, no, because 1.2 and 1.1797. So you can see the first decimal places are already different, right? To meet the requirement, we need the first 5 decimal places to be the same. Okay, so clearly they are not the same yet. So we have to keep updating the solution. Okay, so you do the calculation, x3, it's going to be 1.79509. Okay, 1.179509. So are they the same? Okay, they are very similar now. You can see the first 3 decimal places are the same, but the 4th decimal places are different. Okay, here it's 7, here's 5. So it still doesn't meet our requirement. So we have to keep doing the update. Okay, so x4 is x3 minus fx3 over f prime x3. Okay, now after some calculation, we get the result 1.179509. So now you can stop here because now the first 5 decimal places are the same for these 2 consecutive answers, right? So now we can stop and make our conclusion. So the approximated solution of fx is equal to 0 is just x is equal to 1.179509. Okay.